Hi, my name is Simon Reynolds from the University of St Andrews, and in this talk I'm going to be covering a lot of work that's been done by different people, including Rita Tejero and Paula Miles, as well as different members of the Sloan Digital Sky Survey. You can see here the structure of the talk. I'm going to begin by discussing the project's aims, and then some background on the Sloan Digital Sky Survey and some work that's preceded ours, before then talking about where our project is at the moment, a little bit about the evaluation work that's going on, and some discussion of future work. So the main focus of the project is to embed physical artefacts from astrophysics research into secondary school education in Scotland, and to do this with teacher professional development. And the objects that we've been providing are these telescope fibre plug plates. So from the Sloan telescope, this is an 80 centimetre wide disc of aluminium with 1,000 tiny holes drilled in it for positioning optical fibres on the back of the Sloan telescope. We're going to talk a lot more about these throughout the talk. And the focus of the project is really to try and impact on teachers' self-efficacy and their physics identity. To understand these plates, we need to discuss the Sloan Digital Sky Survey, which is one of the biggest astronomical surveys of stars, galaxies and quasars ever to be constructed over a course of more than 20 years. This work was done by the telescope you can see here, a 2.5 meter telescope in New Mexico, and also more recently by a second telescope in northern Chile. And this telescope really had two jobs, the first of which was with a camera placed on the back of the telescope to take images of the sky. And that imaging covered nearly a third of the whole of the night sky in incredible detail, from ultraviolet to near infrared. And all of that data is publicly available for free. Anyone can access it by going online, and we really encourage our teachers and their pupils to spend some time exploring around in this data to see what they can find. And so, having taken all these images, the survey then wanted to create 3D maps, and to do this you have to measure the distance to any objects of interest in the images. So this is then the second job of the telescope, which is to take spectra using a multi-object spectrograph fitted on the back that can take spectra of 1,000 objects at a time. And to do this, you need a way to position 1,000 optical fibres on the focal plane of your telescope to carry that light through to your spectrograph. Different telescopes have used different solutions for positioning these fibres, including using robots, but for the Sloan telescope they decided to engineer these plug plates with the positions carefully drilled for 1,000 objects in each patch of the sky, and then during the daytime somebody would plug 1,000 optical fibres into those plates, load that into a cartridge, and a number of cartridges would be produced during a day, so that at night they could one at a time load those cartridges, which you can see in the top right here, into the telescope that you can see in the background to make the observations. So over time they built up a huge library of these plates, and once that plate had been used to record the spectra of those objects in that patch of sky, you can then measure a redshift from those spectra, use that as a measure of distance, and you can see here how you can start to see the different populations of objects, like the distance to galaxies, the distance to quasars, and really explore the objects that you're seeing in the patch of sky. Once a patch of sky has been observed, that plate no longer has any research value, and in 2015 SDSS started distributing plates to educators, and since then plates have been placed with teachers around the world. Alongside this, SDSS also developed the Voyages suite of educational resources, which have a really broad range of astronomy activities, some of which actually use the real research data, whether that's the imaging or using coordinates or redshift data. And the Plates for Education program is itself still ongoing in the US. And in 2018, building on that work, the Plates for Education Scotland project started up with a number of different events, including some pilot teacher professional development events. The format that we've settled on for our teacher workshops includes 4 hours of contact time, either in person or online, and we're trying not to dictate how the teachers use the materials, but allowing them to consider how they can best adapt it to use within their own classroom teaching. We're bringing in teachers who've been actively using their plates within the class so that they can share their experiences, and also so that they can provide examples of how they've adapted things to work with their own curriculum teaching. We provide an introduction to the survey, and we also try to make sure that we're providing enough background of the astronomy, enough training, so that the teachers can be confident in delivering these materials, no matter their own background. We then run through 2 different activities. The first is a treasure hunt, where they can explore through the survey's imaging data. And the second is a constellation activity using the school's actual own physical plate, and they can use the survey data to find the 20 holes on their plate that correspond to the brightest objects on that plate. We're currently in the process of expanding the program, both in terms of the number of teachers involved and also the geographic reach. And to do this, we've been successful in getting a public engagement award from STFC, the UK's Research Council for Astronomy and Particle Physics. And we've also partnered with both CERC, who is the Scottish Advisory Service for STEM teachers, and also with the Ogden Trust, a charity that promotes physics education. And together we're working to bring this programme out to more Scottish schools and also to schools in both England and potentially Wales by working with other partner universities. As part of this process, we're also creating a steering group and trying to build a community of practice between the teachers that are part of the programme. The idea here is to allow the teachers to support each other, both by sharing best practice and sharing resources. And to do this, we've provided the spaces for the teachers to interact and the encouragement for them to build this community of practice. We've definitely found that this isn't trivial, though. This isn't easy. The building momentum and maintaining momentum definitely needs regular pushing when everybody is so busy. Alongside the work that we're doing with teachers, we're also working with the School of Psychology and Neuroscience at the University of St Andrews to research into the role that scientific artefacts can have in the professional development of physics teachers. This work is including both questionnaires and interviews with the teachers, and aiming to investigate the impact on the teachers' self-efficacy and their physics identity. And the preliminary results do appear to show that there is a positive impact that the plates are having on teachers. However, the sample of teachers that we have are self-selected in the sense that they signed themselves up for the Plates for Education programme, and so they actually demonstrate quite high self-efficacy and physics identity already. And so we're definitely keen to expand the programme out to more teachers and to keep trying to investigate the impact that the plates can have. There's actually only a limited number of plates still available in the world because the Sloan telescopes have moved away from using plates to position their fibres for future observations. And so I'm certainly interested to see if there's other physics research artefacts that could be brought into the classroom to try and inspire teaching and inspire learning. And I think this really depends on how you present it. The idea of one person's scrap from their lab or observatory being another person's treasure if you can get that into the classroom and present it the right way. If you're interested in hearing more about these programs, please do get in touch. If you're in the UK, you can contact us at St Andrews, or elsewhere in the world, you may want to get in touch with the Sloan Survey's own public engagement team. Thank you very much for listening.